AB Calculus Note Card 61, Integration Techniques. This is the 61st video lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed this note card system. Now, integration techniques. Use these methods for integrating when you have a rational expression and use substitution does not work. And so a rational expression would be something like if you have x over x squared plus 2 or something like that. Now, use substitution might work like that, but we're going to see some examples here. Use long division for integrating when the degree number, the degree of the numerator, is greater than the degree of the denominator. Make sure all the terms are in descending order before you actually divide. And I would suggest instead perhaps using synthetic division. In fact, synthetic division is what we're going to use in our examples up here. Synthetic division, okay? Use complete the square when the denominator is quadratic, and then look for an inverse trig pattern when integrating, and the inverse trig patterns we're going to be looking for are found here from this previous note card number 60. So we're going to go back and reference those. Okay, let's get into some problems. We have integrate the following back in note card 61. There we go. Integrate. And what we have is the degree of the numerator is larger than the degree of the denominator. And so we're going to use not long division, but what most of my students find easier to do, that is synthetic division. So we take from the numerator the value of the 0, which is 1, and then it says here, make sure all the terms are in descending order. And so let's go ahead and do that. So what we have is, we have x to the third power plus 0x squared plus x plus 0 x to the 0 power, which would be the number situation. Okay, so let's go ahead and put these up here, and of course we're dividing by x minus 1. So we put the value of 0 here in the corner, and then the number of x cubed, number of x squared, number of x's, and the numbers of numbers, which is 0. And so we bring down this thing here, so we get 1, which is 1x squared. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 1 plus 1 is 2. And 1 times 2 is 2. So 0 plus 2 is 2. So what we have is x squared plus x plus 2 plus 2 over our divisor, which is x minus 1. So let's go ahead and rewrite this. So we have a replacement with, we have x squared dx plus the integral of x dx plus, I'll just put this 2 outside, 2 times the integral of dx. And finally we have plus 2 times the integral of 1 over x minus 1 dx. These first three are going to be very easy to integrate, but this last one, not as much, in that we're going to take a u substitution. So we're going to say let u equal x minus 1. And so du is equal to dx. And so let's just go ahead and work below here. And I'm just going to, until we are ready to rewrite this thing completely, we'll have integral of x squared dx plus integral of x dx plus 2 integral of dx plus 2 integral of 1 over u du. That's what we do to replace this thing. So integrating, where I'm going to work to the right here, we have x cubed over 3 plus x squared over 2 plus 2x over 1 plus 2. We have the integral of 1 over u du is the natural logarithm of the absolute value of u, and that's going to be plus our constant of integration c. And the very last thing we're going to do is take this value of u and park it back in here. And so our final answer is going to be x cubed over 3 plus x squared over 2 plus 2x plus 2, the natural logarithm of the absolute value of x minus 1 plus c. And there we have it. Okay. Next, here we have in the denominator the square root of a quadratic, and going back to, we're going to review quickly the chart here in note card 60, and there we have it. And so it's going to be one of these things here in the bottom, so we'll just go ahead and proceed and see what's left for us. I think it's going to be this number 8 over here. But let's just go forward and complete the square. So just working to the right, we have the integral of 1 over, now we're going to have the square root of I'm going to take a negative sign out of here, negative, and just switch this around. So we're going to get x squared plus 4x, and we're going to subtract 21. Okay. Now, what we're going to do is, to get a perfect square here, we're going to have half of that middle term coefficient, 4 divided by 2, which equals 2. And we square that. 2 squared is equal to 4. So what we need is this thing to be 4 here. And to be 4, this is what we have to do. Okay, I'm just going to come down 1 over square root of negative. We have x squared plus 4x plus 4. In order to make this plus 4, here, what do we have to add? Well, we're going to have to subtract 25 to make that happen, right? Because we subtract 25, does that make that happen? Well, no, it doesn't. We're going to have to add 25. Why is that? Because that's -4. So that's negative, negative, because we had 21. And does this all account here? This turns up being -4 plus 25, that's negative. So it's all good here. So let's look at what we have on the card. That's going to be number 8. I'm just going to write this on the side. The integral of 1 over square root of a squared minus x squared equals arcsin x over a plus c. Okay, so let's set this to work. We bring down this. We're going to say 1 over square root of, well, this 25 here is going to be 5 squared, and we're going to have minus quantity x plus 2 squared. Okay, and that's going to be, of course, dx. And what that's going to equal, coming to the right, we're going to get, this is going to be our a here, this is going to be our a squared, this will be our x squared. So what we get here is arcsin. We have x over a, and our x is going to be x plus 2, and our value of a is 5, plus our constant of integration c. And so this is going to be our answer for this one. So quite a little bit of manipulation that it takes to get this one, but doable. Let's look at number 3. Again, we have the quadratic in the denominator. So we're going to be looking at one of these here. And I think it's going to be number 6 here when we get done with it. Let's go ahead and take a look at it. Okay. What I'm going to do here is I'm going to rewrite this as 5 over, we're going to factor out, looks like a 2 is a common factor here, so we have 2 times quantity x squared minus 6x plus 13, and then dx. And then what we can do is pull out, I'm going to work to the right here, we can pull out the 5 over 2, so we have 5 over 2, the integral of 1 over x squared minus 6x plus 13 dx. Now to find the perfect square here, we're going to have to take this -6, divide that -6 by 2, our central term, we get -3. And -3 squared is 9. So we need this thing here to be 9. So to do that, I'm going to just right below, we get 5/2 integral of 1 over x squared minus 6x plus 9. And to balance that out, we have to add this 4 on the outside, and we have dx. Okay, and what that gives us is 5/2 the integral of 1 over quantity x minus 3 squared plus 4 dx. Now we go to our number 8 that we looked at earlier, and that's number 6 actually, and I'm just going to write up here, and we're going to use it as a guide. We have 1 integral of 1 over a squared plus x squared dx equals 1 over a arctan of x over a plus our constant integration c. And so let's just go ahead and work to the right here below. We have 5/2, and we have 1 over a, and so that's going to be 1 over, and a is going to be this, well, it's a squared, so 4 is equal to a squared. Okay, so a is equal to 2. And then we have arctan. We have x over a, and in the place of x, we have this quantity x minus 3 over 2 plus our constant integration c. And the very last thing we can do is simplify this fraction out front. So we have 5/2 times 1/2 is 5/4. So we get 5/4 arctan. We have x minus 3 over 2 plus our constant integration c. So that's going to be number 3 worked out. Okay, number 4, we're going back to where we have the degree of the numerator being greater than the degree of the denominator, and instead of using long division, we're going to use synthetic division. So our x cubed plus 0 x squared plus x plus 3, and we're going to divide that by x plus 1. And now we're going to set up a synthetic division here to the upper right, and our 0 for this denominator is going to be -1. So it's like if we set x plus 1 equal to 0, the value of the 0 is -1. So we put the coefficients of x cubed, x squared here, x, and our number right here. So we're going to come down here, and we're going to get 1. That's going to be x squared. -1 times 1 is -1. 0 plus -1 is -1. -1 times -1 is 1. 1 plus 1 is 2. -1 times 2 is -2. And 3 plus -2 is 1. So what we're going to get is the integral of, I'm just going to write it here like this, x squared minus x plus 2 and that's going to be dx, and then we're going to have plus 1 over our divisor, x plus 1 dx. So what we're going to get here, I'm going to just work below. Taking the integral, we're going to get x cubed over 3. We're going to have minus x squared over 2 plus 2x. And then what we're going to do for this 1 over x plus 1, we're going to say let u equal x plus 1. So du is equal to dx. And so we can take this term here and we can make this, we'll say integral of 1 over x plus 1 dx is equal to 1 integral of 1 over u du. And now we're just going to bring this down here. The integral of 1 over u du is plus the natural logarithm of the absolute value of u plus c. And then as a final step, we're going to take this value of u, x plus 1, and plunk it in here for this u in the absolute value brackets. So we have, as our final answer, x cubed over 3 minus x squared over 2 plus 2x plus the natural logarithm of absolute value of x plus 1 plus c. And there we have it. So this is new to the AP test. So that's the purpose of getting these types of problems in here. That when you see this type of problem in the AP test, you're going to have an idea of what to do. To me, these problems 1 and 4 are easier in that I think there's less really to remember. But again, I hope this is helpful. Good luck, and thanks for viewing.